Our next method for solving quadratic equations is called the square root method. And if you'll notice the three problems that are on the screen, these are all quadratic because they all have an x squared term, but they are missing the usual or the normal x term. If that's the case, then we can solve these using the square root method. And in that, what you do is you isolate the x squared term. So in the first step, I'm going to add 49 to both sides. Now I'm going to divide by 4. So x squared equals 49 over 4. And now I take the square root of both sides. So x equals plus or minus the square root of 49 over 4. X equals plus or minus the square root of 49 is 7, and the square root of 4 is 2. So we have two solutions. We have a positive 7/2, and we have a negative 7/2. Now, let's put that into the calculator and see if our graph agrees with our solutions. So I'm going to go into y equals. I'm going to type in 4x squared minus 49, and I'm going to press zoom 6. And what we're looking for is 7/2 and negative 7/2 as being the x-intercepts. So press trace 7/2, and we get a y equals 0. Press trace negative 7/2, and we get y equals 0. Therefore, our solution is correct. Let's do the same thing with our next problem. This is x squared minus 12 equals 0. So if I add 12 to both sides so that I can isolate my x squared term, I have x squared equals 12. Therefore, x equals plus or minus the square root of 12. Now that is unsimplified. We need to simplify the square root of 12. And if you're not very familiar with simplifying square roots, the easiest thing you can do is make up a little factor tree. 12 is 2 times 6. 6 is 2 times 3. And if we can circle every pair of factors that ends up at the bottom of the tree, then we can simplify this radical. So x equals plus or minus, the pair that we circled is 2. So I just write down a 2, and then the remaining term that's at the bottom of the tree goes underneath the radical. That's the same thing as thinking of 12 as 4 times 3, and the square root of 4 is 2, and then we have the 3 remaining. Now these numbers are not as easy to determine unless you know how to solve algebraically. So let's go to our calculator, and we're going to type in x squared minus 12. And you can see that the graph does not go through any whole numbers. Let me test these answers. Trace 2 times the square root of 3, and I get a 0. And then I'll do negative 2 times the square root of 3, and I also get a 0. So there's my solutions right there. Our last one is x squared plus 4 equals 0. So if I move the 4 over, I would have to subtract it from both sides, and then take the square root, and I'd have plus or minus the square root of negative 4. Now remember that the square root of -1 is equal to I. That's an imaginary number. So x would equal plus or minus, the square root of 4 is 2, but it's negative, so that would be 2i. Now what does that mean in terms of our graph? Remember, the x values we're finding are our x-intercepts. So if I go in and I graph x squared plus 4, I hope you notice that there are no x-intercepts. This graph opens up and it never crosses the x-axis. Therefore, there are no x-intercepts. And we know that from the fact that we got imaginary solutions. So there are no x-intercepts.